Hello everyone, my name is Winston. Today I'm going to talk about alpha and beta pruning, which is a technique used in Minimax. The reason why I started learning alpha and beta pruning is because I was trying to implement Minimax to my ultimate Tic Tac Toe. So before I start talking about alpha beta pruning, I would like to talk about the problem that I face when I try to implement Minimax to automate Tic Tac Toe. In order to implement Minimax to automate Tic Tac Toe, I figured out that I may need two variables. One is global board, which represents the 9 minor boards 0 to 8, and then the variable local board. And it is also an array, but for each value in the array, it represents the 9 squares. So together in the local board, there are 81 squares. So for the one player to win, we still have the same winning conditions, but we only look at the global board. So let me explain how the global board variables works. So if I put a move here, the other minor boards will become unavailable to play. So the global board will become like this. So, and then the second player can only play on the 5th board. And also because I have already made a move here, the local board will become here, like this. And while the game is going on, when, for example, a player wins one of the minor boards, it will also reflect in the two variables. For example, if a player 1 wins this minor board, here will become X to show that player 1 has won the board. And also if the move in that board will also be reflected in the local board. For example, like this. But of course the second player will also make some move, and just for example, so that's why in my Minimax, if you have watched my previous video about Minimax, I have only one board, but here in this function for ultimate Tic Tac Toe, I have added one more variable. So there's one global board and one is for the local boards. Since in the ultimate Tic Tac Toe game, when the player makes their move, it will also determine where the next player must play. So I have also reflected that in the Minimax function. So here I have made other boards to become unavailable after the player make a move, and then only the board that the next player can play is available as long as a number. And also, if all the squares in the minor board have been filled up, that minor board could not be won by either player. So that minor board will become draw as D. And if one of the player wins the minor board, it will reflect in the global board variable to show as either X or O. However, when I try to implement Minimax, I face a problem. So in a board, there are 81 squares, and each of the moves will determine where the next player must play. So I'm guessing it took too much resources for the function to work, and so my browser got frozen at the end. So in the function here, I have logged all the possible moves, but when I try to make a move and then let the function to calculate the next move for the AI, my browser just got frozen. Let me show you here. So as you can see, the function is calculating all the possible moves and determine which move the AI should play. But at the end, my browser will got frozen. I asked ChatGPT what may be the reasons that make my browser got frozen. And ChatGPT said that I may need to optimize my code. So I asked him how, and then he gave me some suggestions. And one of the suggestions has got my attention because the name is so cool. And it is called alpha and beta pruning. And as a spoiler, I have to say that ChatGPT didn't give me much help in terms of how to implement alpha and beta pruning in my Minimax function. For example, I asked ChatGPT how many looks for Minimax to explore in a new Tic Tac Toe game, and then he gave me the answer. There are 45 looks. And then I asked him how about Ultimate Tic Tac Toe game, but he gave me 81, which means that either one of the answers he gave me is incorrect, because for Tic Tac Toe he said 45, but for Ultimate Tic Tac Toe it's only 81, so must be one of the answers is wrong, or both answers are wrong. If you paste your function and ask ChatGPT to add the alpha and beta pruning to the function, it will never work. Anyway, let me explain what alpha beta pruning is. As I mentioned in my previous video, Minimax is to explore all the possible moves to find the best move. So for alpha beta pruning, as you can see here, those in color gray means that these are the branches Minimax is not going to explore, which can save the computer's resources. How it works? So for Minimax, we can see all the possible outcome. So we need to look from the end to the beginning. So as I mentioned in my previous video, each player have different goals. One player is to make the maximize score, while the other one make the minimize score. So for here, for the minimizing player, to choose either 5 or 6, he must choose the smaller number, which is 5. And for here, there are 3 numbers. However, for alpha, beta, or for Minimax, we iterate all the possible outcomes, possible looks from the left to the right. So here, you have 7 and then 4, so the minimizing player will get 4. However, for this branch would be ignored, because for the maximizing player, there's only number 5 and 4, he must choose the larger number, which is 5. And for this branch, no matter what the number is, even if this is smaller than 4 and the minimizing pair pick that number, for example -1, and minimizing pair take -1 here, is only between 5 and the smaller number, and the maximizing pair will always pick 5. And even if this number is greater than 4, for example 10, the minimizing pair here will never pick that larger number, so it will just stick as 4. Therefore, this branch is irrelevant, and so Minimax should not waste the computer resource to explore this branch, and same as this one. And for this branch, after we have iterated all the other possible nodes from the left to the right here, so we arrive here, and the maximized pair pick 5 here, and then the minimizing pair here, because it's only one number, so minimizing pair will pick 5. And for this branch, we will not need to consider it, because for the maximizing pair, he can only choose either one of the 3 numbers here, and minimizing pair here will not choose any number greater than 5, so we don't need to explore this branch, because the maximizing pair will only pick number 6, because minimizing pair will not pick something greater than 5 here. Therefore, by not exploring this branch, it can help saving the computer resources. And now, let's look at our updated code. Please note that at the moment I have only implemented alpha and beta pruning for Tic Tac Toe only. Since I'm still learning and ultimately Tic Tac Toe is a bit more complicated, so I will properly implement it in future. So you can see from the code here, we have 2 more variables. One is alpha and another one is beta. In order to initialize this function, we need to set alpha as -infinity and beta is infinity. So alpha is for maximizing pair and beta is for the minimizing pair. As you remember, the maximizing pair will need to get the largest score. So for this picture, the minimizing pair need to choose either 5 or 4, whichever is smaller. So the minimizing pair will choose 4, and 4 will be the beta. And the reason why Minimax will ignore this branch is because no matter what this number would be, maximizing pair will not be able to pick that number, because for the minimizing pair, it will get something smaller than or equal to 4. So for here, alpha can only choose between 5 and 4, and 5 would be the alpha. And now you can see alpha is greater than beta. So when Minimax ignore the leftover branch, you can see that alpha is greater than beta. So it also reflects in my updated function. And here, so for every possible move, I have included it in the all possible moves array. But if beta is smaller than alpha, which is alpha is greater than beta, then I will break the for loop. So this move will not be included in all the possible moves. Therefore, when Maximize try to find the move with the highest score for maximizing pair or lowest score for minimizing pair, there will be fewer moves to iterate, which can help saving computer resources. And because when we loop all the possible moves, we have also updated our alpha and beta. So when we try to find the best move, instead of iterate all the possible moves to find the highest score, we just need to find the move with the score equal to alpha for the maximizing tail, or the score equal to beta for the minimizing tail. So when we find the move with that score, we can just stop the loop. Remember that if the function is not having alpha and beta pruning, we will need to loop the whole array in order to find out which move has the best score. So with alpha and beta pruning, we can just stop the loop the moment when we got the move with the score of alpha or beta. So we can stop the loop sooner, which means it can help saving the computer resources. And now let's test this updated code. And notice that I have added this line to show how many moves that the Minimax function will have to iterate. So here, this is from the console log move. As you can see, now Minimax just need to iterate one move only, because this move will be the one that AI, the minimizing player, need to play. And for other moves, it will make the player very likely to lose. So now with alpha and beta pruning, Minimax will just ignore all the other moves. So the function will just need to iterate one move only, which is very good for saving computer resources. And now we can compare with the Minimax without alpha and beta pruning. So here I just include all the possible moves without pruning, and then in order to choose the best move, you will need to loop all the single move in order to find the move with the best score. So it will use up more computer resources. Now take a note that the total messages for Minimax with alpha beta punching is around 17,000, and now we will do the same test with Minimax without alpha and beta pruning. The same, I have added a console log here. As you can see here, now Minimax will need to iterate all the 6 possible moves instead of only iterate one move. And you can see the total number of messages is 30,000. Therefore, Minimax with alpha and beta pruning indeed save more resources. Oh, actually, I have some question regarding to alpha and beta pruning. As you can see here, what if this number is 5 with alpha beta pruning? Ignore this branch. I think so. So is it supposed to be if alpha is greater than or equal to beta, then we will ignore this branch. However, in my code, I only put alpha greater than beta because I found that if I put alpha greater than or equal to beta, it will give me a suboptimal result. And I have done some Google search, and I can see many people also have the same question. But if I look at the wiki page, it says alpha is greater than beta, so we will not include alpha is equal to beta. But if we ask ChatGPT, it will show that it will be alpha is greater than or equal to beta. In fact, when I first tried to implement alpha beta pruning, I tried to follow the example given by ChatGPT. So in the beginning, I have put alpha is greater than or equal to beta, but it just didn't give the result I want. So at the end, I changed it to greater than beta. So here, I'm a little bit confused because if we just look at the graph, I would believe that even if the beta is 5, we should ignore the leftover branch. So it would say alpha is greater than or equal to beta. But the wiki page and my code say otherwise. Therefore, if someone knows the answer, I would be very happy to learn from you. This is the end of my video. Hopefully you will have some little understanding about what alpha beta pruning is. Thank you for watching. Bye bye.